Hi there. Welcome to Xamarin University. My name is Mark Smith, and in this lightning lecture, I'm going to walk you through the process of updating your Xamarin.iOS applications to Apple's newest mobile release, iOS 9. I've got several things I want to cover in this lecture. First, we're going to look at the basic steps you'll need to do in order to ensure that your applications run properly on iOS 9. As part of that, we're going to examine a few minor tweaks that you might have to make to your code to make sure that it continues to work the way you expect it to. Then we're going to get a little deeper into iOS 9 and talk about how you could begin adding new features into your app to begin leveraging the new capabilities that have been introduced in this release. So we're going to cover this in two phases. First, we're going to look at what the minimum requirements are to getting your app ready to go on iOS 9. For this, I'm going to assume that you already have a published app and you simply want to make sure it continues to run properly on new and updated devices. In this case, you won't necessarily be adding any new features to the application at all, just ensuring compatibility with the new release. Next, we'll look at what you need to do to begin to leverage iOS 9 features in your application. In this case, you will be updating your development tools and actually making some modifications to your code to use new APIs. And as part of this, we'll talk about how to properly structure your code so that you can continue to run on older versions of iOS while still accessing some of the new APIs. So let's start with the minimum bar, making sure that your app is compatible. There are really just a few simple steps that you will need to take for this. First, you should know that you will need to recompile your application. This is necessary because of some of the changes in the API which unfortunately break the Xamarin.iOS binding layer. The result is that most Xamarin.iOS applications will not run properly when installed on an iOS 9 device. Second, depending on the APIs that you're using today, you might need to make a few minor tweaks to your code to run properly on iOS 9. Finally, you'll want to fully test your application on all versions of iOS that you want to support, and then resubmit your app bundle to Apple to get it into the App Store. So let's look a little more closely at these steps. As I just mentioned, there are a few breaking changes in iOS 9 that cause some Xamarin.iOS applications to not execute properly. These were caught and fixed very early in the iOS 9 beta cycle, but to make sure that you have these fixes, you should update to the latest stable channel release of Xamarin.iOS. Make sure to do this on all of your development machines. So if you use Visual Studio, for example, you'll want to make sure that you update to the stable release on Visual Studio as well as your build host. Apple also released Xcode 7 to coincide with iOS 9, and the stable channel provides compatibility with the new SDK. However, it's not a requirement to update to Xcode 7 yet, and if your goal is just compatibility, then you can keep Xcode 6.4 installed and use that. Just keep in mind that you won't be able to use any of the new iOS 9 APIs. Finally, if it's an existing application, then you'll likely want to allow your app to continue to run on at least iOS 8 or perhaps even older releases. This is done through the deployment target setting in your project properties, as you can see here on the slide. This setting determines the minimum operating system version that your application is capable of running on. Again, if your goal is to just have compatibility, then I would leave this setting at 8.0 or whatever you want to support. We'll talk about using iOS 9 APIs a little bit later in this talk. Once you've got your development tools ready, there are a few new initializers that iOS 9 introduced which might affect your application. For the most part, these are edge cases that most apps won't run into, but there are two that I want to specifically call out because it's possible that you might be impacted. First, if you're using the UI Collection View class today, and you've created your own UI Collection View cell derived class, then you should add a new constructor to your cell class to conform to the initWithFrame initializer. This is now required by iOS 9 due to some behavioral changes in the API. Leave your existing constructors in place for older iOS versions and just add this new variation and then refactor your initialization code to be called by all the constructor variations. The second one is very similar, but less likely to hit most developers unless your app has been around a while. When you load custom UI views from zip files, iOS 9 will now use the initWithCoder constructor. In earlier versions of iOS, the system invokes the standard int-pointer constructor. So if you're using zip files and you have custom classes that derive from UI view, which are inflated from these zip files, then you'll need to add this new constructor to your class and make sure to export it, as you can see here on the slide. Just like the collection view cell constructor, you should leave your existing constructors in place and just add this new one and make sure to call the same initialization code to set up your view. Finally, there's one other that comes to mind. If you're deriving from UI table view header footer to create a custom header or footer for a table view, and you're using the view reuse feature, then be aware that the default initWithFrame constructor is not called anymore for iOS 9. Instead, it only calls the initWithReuse identifier initializer. This initializer was actually called in earlier versions of iOS as well. The change is the system won't call the original initializer if the reuse version is not present. This likely won't hit many apps because most applications just use the standard class and they customize the text and the colors rather than deriving completely from it. So these issues might seem a bit obscure and worrisome to try to figure out where to find each of these changes. The Xamarin documentation team has been busy keeping up with all of these, however, and we've got a great troubleshooting page which lists all the known breaking changes in the API which have hit people already and the workarounds necessary to fix them. The link is here on the slide, and this is a live page that will continue to update as more of these odd inconsistencies are found. So make sure to check this out after the lecture just to see all of the things that people have encountered, and be aware that most of them are fairly edge cases. It's very likely that you won't make very many changes at all to your application. All you'll really have to do is recompile. Okay, so you've made some tweaks, and you've rebuilt your app on the stable channel. Now what do you need to do? Well, as with anything, you should make sure to test your app thoroughly. Every release of iOS has known, documented changes, and then a bunch of changes which Apple doesn't mention that might impact your application. Just as an example, in one of my own applications, I experienced a crash when an auto layout constraint was being changed at runtime. When I tracked down the problem, I found that it was my own error. I was trying to create a constraint between a leading space edge and a left edge attribute, and that's not a valid attribute pair. However, it worked in iOS 8. The system let it slide and it translated the left edge attribute into a leading space attribute. But in iOS 9, it crashes and gives me an error because it now considers that parameter invalid. And so be aware that there's a little more parameter validity checking that's going on in iOS 9 that might impact you. In this particular case, it was my own bug, and so it's really just exposing a problem that was already in my code. It just worked before and doesn't work now. So we recommend that you test on physical devices and make sure to not just test iOS 9, but if you're continuing to support iOS 8 or earlier, then run it there too. Xamarin Test Cloud is a great resource to use for things like this. You can script basic UI tests using either Xamarin UI Test or Calabash, and then run it across a whole set of devices with different operating system versions and capabilities to make sure that it executes properly. And remember that every Xamarin subscriber gets 60 Xamarin Test Cloud device minutes free every month. So if you're not taking advantage of that, you should be. Of course, you can also test on simulators. Now, Xcode only installs the latest versions of the iOS simulator by default, but you can open Xcode preferences and then use the Downloads tab to go download older versions to test with. Just remember that simulators are not a complete replacement for a real device test. They're great for quick testing and for debugging and development, but make sure to test your app completely on a real device as well. Finally, if your app is distributed through the App Store, then once you've gone through the testing phase, generate an app bundle using Xamarin Studio and submit it to the App Store for publication. As of today, just after the iOS 9 release, it's taking about a week or so to get through the review process. That will eventually settle down and things should go back to being a bit more smooth, but expect delays as everyone gets their apps updated and submits new versions. Once your app is compatible and you've got your app in the store for your users, which works on iOS 8 and 9 or whatever version you need it to, then you can start looking at leveraging some of the new APIs in your app. To do that, you're going to need to update to Xcode 7. So this is where you'll find all the new SDK libraries. And to use any of the new iOS 9 APIs, you absolutely will have to update your Apple development tools. And eventually, of course, Apple will require you to update to Xcode 7 anyway. Be aware that once you update to Xcode 7, you will be linking to the new libraries, and the iOS runtime will treat your app a little bit different for a few things. So let's look at what's going to change. First, as I just said, a big benefit is you'll have access to the new and updated APIs that have been introduced in iOS 9. For example, we now have multitasking and split screen support on iPads. We have a new hardware feature, 3D Touch, or called Force Touch sometimes, which opens up new ways to interact with your applications using new peek and pop capabilities. Search is particularly useful. In fact, I would say that if you pick any particular API to implement your app, search would be it. iOS now allows your app content to be searchable through the System Spotlight service, so users can search for content and then jump right into your application from the search screen. There's a ton of new gaming improvements. There are new frameworks such as Gameplay Kit, which helps you to build your game logic with built-in AI support for turn-based games and state machines that will drive more complex game interactions. There's a whole bunch of new 3D capabilities and deeper integration with hardware for better gaming performance. And then add to that all kinds of new and updated APIs in the core frameworks. For example, we'll see a couple of the new features that are in UIKit in just a moment. And we've got support for integrating the full Safari browser into your app with a new view controller. And there's some new extension points for the operating system to enable new ways for components to influence operating system level activities. So there's a ton of new things that you can take advantage of in the iOS 9 API itself. Now, the stable channel has bindings for all of these new APIs. In fact, they were available the day iOS 9 was released to the public. However, most of the time, you're going to want to keep compatibility with iOS 8 or earlier, and that means being a little bit careful about the APIs that you call and how you call them. For example, here we've got some code to detect the new 3D Touch capabilities. We want to know if we're running on a cool new iPhone 6s device. But if our app still supports iOS 8, in other words, our deployment target still says 8.0 as you can see here, then the code that we show here on the screen would be very dangerous to run. In fact, Xamarin Studio would try to help us and warn us about this condition by drawing little squigglies under the new APIs. And if you hover over that, it'll display a tooltip indicating that this API is new for 9.0. If we ignore the IDE and we just run this code on an iOS 8 device, then we'll get a fun runtime exception. Notice the text of the exception, unrecognized selector. That's iOS speak for you called a method or a property which doesn't exist on this object. Now you might think the compiler could catch that, but we're now linking to the iOS 9 SDK libraries, and so the compiler assumes that you're going to run on that set of libraries as well. The IDE is smart enough to try to warn us, but it's not an error as far as the compiler is concerned. And because iOS dispatches things in a dynamic fashion, we simply get a runtime exception if we invoke an API that doesn't exist. So what do we need to do to fix this? The answer is quite simple. We just need to check what version of iOS we're running on before we actually execute the code. The UI device current device check system version API returns true as long as the runtime OS version is at least the past value. So here we're asking if we're running on at least iOS 9 or better, and if so, then we're going to go through our if logic to see if we have the 3D Touch capability. Now, this is a simplistic way to alter our code. You could use abstractions on top of this. For example, perhaps I would create a specific initialization function, one for iOS 8, one for iOS 9, and then point a delegate at one of those two functions and invoke them based upon the runtime version. The key thing is checking the runtime version before you execute the code, and that's what check system version will do for you. So keep your apps backward compatible and fall back gracefully if you can by utilizing this API. Okay, so this next piece of advice is given with a little trepidation. If you're adding in new iOS 9 features and you've upgraded to Xcode 7, it might be wise to check for component and package updates. Several vendors have updated their components for iOS 9 capability or to leverage new features in the operating system. However, updating components can also break your app in horrible ways. We've all experienced that. So my advice would be to check for updates, but be judicious in which updates you actually apply. Read the release notes and see what's changed and why, and then decide if it's worth the risk to your app's stability. If the current component is working for you, then perhaps it'd be better just to keep with the current component unless there's a compelling reason not to. Now, one of the coolest new features in iOS 9, in my opinion, is support for simpler layout constraints. Anyone who's ever done any work with auto layout knows what a beast it can be. And iOS 9 introduces some new, simpler layout APIs which will do all the heavy lifting for you in many cases. In particular, there's a new UI stack view layout control which will create constraints for you to keep content lined up vertically or horizontally. It's great, and I, for one, am glad to see Apple finally embracing this sort of layout. However, the support for these new UI features isn't in the Xamarin.iOS designer yet. The designer work is in progress, and I expect that we'll see some support for this hitting the build channels fairly soon. But until then, if you want to take advantage of these new features, you can, but you'll have to use Xcode to do it. So you'll have to be on a Mac. So if you're a Visual Studio user, switch to your Mac build host and open the project with Xamarin Studio. Then right-click on your storyboard and select Open with Xcode Interface Builder. This will create a temporary project for Xcode, fire up Xcode and load the storyboard, and there you can make your changes, add a UI stack view, do some constraints, all that jazz, save the file, and then switch back to Xamarin Studio on your Mac. Be aware that once you add some of these new UI bits into your storyboard, the Xamarin Designer will be unable to edit the file until we get our designer support added. You'll get an error indicating that an unsupported exception was thrown in the designer window with an option to open the storyboard in Xcode. Finally, just so you know, there's a great walkthrough on using UI Stack View in our documentation, and we've got a fun lightning lecture on using UI Stack View as well. Both of these use the Xcode approach, so you can see exactly how that works. Another UI change which you should think about using is launch files to provide your launch screen. Launch files were introduced with iOS 8, and they allow you to define your launch screen using either Zib or a storyboard file. These are more adaptive in nature, so the screen scales properly on different devices. And this is going to become more and more important as more devices continue to be introduced in the iOS family. If you're using launch images today, in other words, individual screens for each one of the devices, then consider adding a launch file for current iOS support. In fact, this is going to be a requirement in the future, and it is today if you want to support the iPad split screen, because your app can be in a variety of sizes when it's launched in that case. Keep in mind that you'll still want to include launch images if you want to support iOS 7 or below, and that if you don't use a launch file, then you have to include larger launch images to support iPhone 6 and 6S, or you're going to be letterboxed with black bars on the top and bottom of your application. iOS 9 is mostly new and changed APIs. However, there was one API that they completely deprecated and replaced, and that was the address book and address book UI frameworks. These were somewhat painful to work with, and so in iOS 9 there's a new game in town for working with the address book information, and that's the contacts and contacts UI frameworks. Here on the slide you can see an example of looking up a list of contacts using the new CN Contact Picker View controller. These new APIs are much easier to use, and they provide a lot more flexibility in filtering and working with the built-in address book data. If you use the address book APIs today in your app, consider replacing them with these new APIs to be compatible going forward. Keep in mind that these are only available on iOS 9, so if you plan to support iOS 8 or earlier, then you'll need to use both APIs in your application depending on which version you happen to be running on. So I saved the best for last. One of the big changes in iOS 9 is a concern for privacy and security. Several APIs were tightened up to try to protect the user's information and provide tighter security as information comes onto or leaves the device. If you rebuild your app with Xcode 7 and the new SDK, then there's a chance that these security changes will impact your app. Existing applications built on the older SDK are not going to be affected. However, keep in mind that Apple often forces developers to update to the latest SDK fairly quickly after the release. So whether you move to Xcode now or later, eventually this might impact your application. The first big change is a new feature called App Transport Security. Mobile devices are often connected to insecure networks, either over cellular or public Wi-Fi. Transferring data over these networks with unsecured connections is dangerous because there are a variety of tools and ways to listen to network traffic. Apple is trying to mitigate some of these data loss issues by enforcing secure communications at all times on iOS 9 and macOS El Capitan with App Transport Security. App Transport Security encourages better privacy by imposing a number of security best practices, the most important being that the network requests need to be sent over a secure connection. So what does it do? Well, it ensures that every network communication done through the platform network stack uses TLS 1.2 or above, uses a modern key exchange and cipher algorithm to ensure that short-term session keys can't be derived from long-term asymmetric secret keys when the key negotiation occurs, and that web certificates have to be signed with a high security key. Invalid certificates that have expired or are not signed with a high security encryption algorithm will now result in a hard failure and a dropped connection. So there's a technical note that's listed here at the bottom of the slide that you can check out for all the interesting details. But before you get too excited, be aware that if your application is currently using HTTPS and good certificates, then this change will likely not affect you. It still might affect you and you need to test, but for the most part, this is really about making sure that our connections are secure. So what does this API affect? Well, first, it affects the native iOS stack. That means places where you might be using NSURL session or NSURL connection or CFURL. Now that's going to include things like embedded web views. So if you use UI WebView or WK WebView, then you're going to hit ATS restrictions. And it's going to be fairly obvious because you'll try to navigate to http www.xamarin.com and it will fail. Now, what it's not enabled for are things like HTTP client and web request or the full Safari experience. So if you use the new view controller that actually puts Safari inside your app, then ATS won't actually affect you. And HTTP client and web client are both implemented with the managed.NET stack, and so they don't go through the native stack, and therefore they're not subject to these restrictions. However, if you use things like modern HTTP client, which is a NuGet package that adds new features into HTTP client, one of those features is that it goes through the native iOS stack. And so if you're using that component, then ATS will absolutely be enforced for your network connections. In addition, things like background transfers use NSURL session, and so those are going to be subject to ATS as well. Now, make sure to test edges of your applications that perform network access, things that you may not even consider, particularly third-party SDK connections. Stuff like social networking interactions. Facebook and Twitter both would fall into this. They supply an SDK, and that SDK is making connections on your behalf. They both have technical notes to talk about ATS and specifically what you'll need to do in order to make their SDK function with the presence of iOS 9's new security requirements. So make sure to test all of your network connections to ensure that you don't fall into this category. Violations of this policy are going to result in an exception of some kind, and so here you can see a web exception thrown from modern HTTP client. You'll also get a debug log message which will list the issues that ATS has with your network connection. The most common reason that you're going to have is that you're accessing insecure endpoints. But I've also seen errors due to older key exchange algorithms or older versions of HTTPS being utilized on the server side. If this does happen to your app, then you have two choices. You can either change the endpoints to adhere to the ATS policy, or you can opt out of ATS for certain URLs by setting some keys in your info plist. So let's take a look at this second approach. When you can't control the server side and you still need access to the data, you can explicitly define the URLs that you need exceptions for with ATS. This is done through a new key in your info plist called NS App Transport Security. It has a dictionary child with various option keys that you can add, and the most important one is the NS Exceptions domain key. This also has a dictionary child which has one or more endpoint targets that you want to configure for ATS. The best practice here is to identify the specific endpoints that you need to communicate with and then add them into this list. Each one is listed as a key with a dictionary set of property options. Each option that you add to the endpoint URL can have one or more options associated to it that act as key value pairs. The keys correspond to the specific options documented by Apple, and the value is typically a Boolean or a string element. So there's several things that you can control, as you can see here on the slide. I want to point out two of them. The first one is that you can change the minimum TLS version required. Remember that it defaults to 1.2, but if you have an older web service that you're talking to, you can set the NSException minimum TLS version key to go as low as TLS 1.0. Second, you can also support accessing domains with no certificate, in other words, over HTTP in plain text, or where the certificate is in error because it's self-signed or expired, or there's a hostname mismatch. This is enabled with the NSException allows insecure HTTP loads flag, and you have to set the value to true. This is probably going to be the most common thing that you'll do until you can get all your servers to be secure and up to date. Finally, you can actually turn ATS off altogether. This can be useful if you can't identify all your endpoints. For example, perhaps some of the URLs are open based upon user configuration or input. In this case, you can disable ATS for all unspecified endpoints by setting the root NSAllows arbitrary loads key and setting the value to true. By itself, this will essentially disable ATS for your app. And this can be a reasonable solution for many applications, but it also opens you up to potential security risks. So a good practice if you use this flag is to then add your own known domains, like we've done in the previous slides, but use the URL specific settings to turn ATS back on for that URL. Essentially, this would mean adding the NSException allows insecure HTTP loads key and setting it to false in this case for the specific endpoint to force HTTPS. The second interesting security change that Apple has made is to the UI application shared application can open URL method. If you aren't familiar with this method, it can be used to see if an application is installed that can handle a specific URL scheme. So many social networking applications such as Facebook and LinkedIn register private URL schemes so you can launch their app directly from a web link or a mail message. Some applications were misusing this API, and instead of using it to detect and open an app, they were scanning your device to see if specific applications were installed, particularly competitor applications. This is a clear violation of privacy, and so Apple wants to prevent apps from being able to just arbitrarily scan your device to find out what apps are installed. So to address this, the CanOpenURL API will now always return false unless you specifically whitelist the URL scheme in your info plist with a new key. That means that if Twitter wants to scan your device, they're going to have to list all the schemes that they're looking for and then explain it to the reviewer as to why they need to look for those schemes. Now be aware that this change does not affect OpenURL. So CanOpenURL might return false, but the URL might actually be usable because the app really is there. In addition, system schemes such as HTTP, HTTPS, SMS, and TEL are automatically whitelisted for your application. So we've looked at the basic steps of making sure that your application runs properly on iOS 9 and how to begin to integrate some of the new APIs into your app. Where do we go from here? Well, we've got some more Lightning lectures available or about to be published which cover iOS 9 APIs in more detail. In addition, there's a ton of documentation available from developer.xamarin.com that goes through sample code and shows you how to use these new iOS 9 features in your apps. So make sure to take advantage of these resources so you can enhance your application. Thanks for watching this lightning lecture on migrating your app to iOS 9. I hope you found it to be useful and informative. If you have any questions, you can reach me at the email listed here, and I periodically troll the forums as well, so you might see me there sometimes. Thanks again, and have a great day.